Hello, everyone. Today, we are excited to give you the final update of our project on Pokemon classification. In this project, we aim to automatically determine the type of Pokemon using deep learning techniques. As the variety of Pokemon skyrockets, identifying their types accurately can be challenging. Each Pokemon belongs to one or two types, which determine their strengths and weaknesses in battles. Our goal is to develop an automated classification system to assist players in understanding the type, their advantages and disadvantages. Our dataset is sourced from two cargo repositories. The first dataset provides high-quality images with uniform backgrounds, and the second dataset offers comprehensive labeling, including JSON files.
So in order to achieve these goals, we first need to combine two sources into a same one, and we need to do the first is the image standardized, and after that we want to make sure each image matched with their particular attributes. The each image's JSON file is look like at the right side. It contains each Pokemon's their type, their height, species. In the next in the next slides, I want to introduce for the data pre-processing, we split our data into three different type: the training, validation, and test. And for the labels, since each Pokemon can have one or either two types, we merge the type 1, type 2 columns into a single list. Then we use the method to turn them all the list into a 18-dimension multi-held vectors. So each slot marks their possible types. So as you can see in the right side, it shows we have about 18 different types, and we can easily say the type is unbalanced. So in conclusion, for the input and output, with each files and follow their pattern with their particular image paths, and all images was uniformed into the same size and loaded. For the output, we want to predict the 18-dimension multi-hot vector to want to demonstrate like each Pokemon belongs to which type it is. For example, like one, if you can see here, the one marks there belongs to the dark, and zero means they're not. Next.
Okay, our baseline model is a mobile net, which employs a module called bottleneck layer to make the model parameter efficiently. And we pre-train mobile nets with two on image nets to gain the basic image vision capabilities. And we also modify the classifier using custom MLP. And for our approach, we choose vision transformer since we had to use self-attention to model the relations between all patches in the image. This is useful for our multi-label test settings where multiple possibly spatial distance features contribute to the prediction. And WIT also has several other benefits such as scaling, better scaling, and implicit attention, which can better enhance our ability to judge the types of Pokemon. And since the compatibility problem of the dataset, we only have a very small dataset to train, validate, and test in our tasks. So we need data augmentation, and we employ more data augmentation compared to the baseline approach, such as randomly vertical flipping, random rotation, color jitter, random size crop, and random offline. So by doing so, we enlarge the dataset much more. So here is the performance comparison. As we can see, our approach steadily decreased the losses both for the training and validation. And after 30 epochs, our training losses decreased to about 0.1, which is a little bit better than the baseline. And what's more, our validation loss is much good than that in the baseline. And on the right side is top K accuracy performance. And we can see that after 30 epochs, our accuracy for the validation is above 0.3 while for the baseline, it's below 0.3. And for the evaluation metric, we also use Hamming accuracy, which measures per label accuracy for a better judge for the whole accuracy evaluation. As we can see that our Hamming accuracy is 5% above the baseline, which means our data augmentation and model architecture did some job here. Team member experiences. Our team members more or less have some experience for deep learning and data engineering. However, it's our first time to handle the multi-label tasks and to play around with Pokemon type prediction. So here's the reference. Thanks.